Welcome back. So in this section, we look at a number of functions from the standard IO library, stdio.h. And so these are basically all related to getting input and putting out output. And here's a list of functions I'm going to go through in this section. There's the getCharacter function, which can be used to receive one character, the next character, from the standard input as an integer. A standard input, by default, usually refers to keyboard input. And we also have the fgets function, which returns a pointer to a character or character array, meaning a string. And what this does is it takes as input characters from a specified stream, that is the third argument over here, into an array S, that is the first argument, until a new line or end of file character are encountered, or until we hit the maximum limit of the array, which is n minus 1 bytes, and that n is specified as the second argument over here. Then we have the putCharacter function. This one's straightforward. You give it a character as an argument, and that character gets printed out to screen. We also have the puts function that we've already used, have been using for quite a while now, which prints out the string passed to it in the argument, followed by a new line character. We then have a relative of the printf statement we've been using. And that is the sprintf function, I should say, the sprintf function. The S stands for string. And what's the difference between the printf and sprintf functions? Well, the printf function sends output to the standard output, which in our case is usually the screen. But the sprintf function sends output to a string. Which string? The string whose pointer we give it as the first argument. And as a counterpart to the sprintf function, we also have an scanf function. Now this works similar to the sprintf function. This is the counterpart of the scanf function, which we typically use to take input from the keyboard. But this one takes formatted input not from the keyboard but from a string. Which string? The string whose pointer we pass it as the first argument. Now we are doing all of our work on Microsoft Visual Studio or Visual C in Microsoft Visual C++. And there will be some variations to some of these functions because of the platform that we're using. Just like we are using the secure version of the scanf function, we will be using secure versions of scanf and sprintf. So let's begin with an example that uses the fgets and putchar or putCharacter functions. So a little bit about the putCharacter function. Again, this is simply used to print a character that we give it as argument. The fgets function has more arguments and is more interesting. So this one reads characters from the standard input, like I mentioned, first argument into the first argument that we give this function. And that first argument has to be an array of characters. And it'll do so until we hit a new line or end of file character. The max number of characters is what we provide, +1 is what we provide as the second argument, and the third argument specifies the stream from which we want to read characters. We will be using the standard input stream, or stdin. By now, you should expect this. The last character that will be written into the array will be the null character, which will simply be appended. And here's a very simple example program. We define a symbolic constant size, set it to 80. We define a function prototype of a function called reverse. And what this program does is it takes from the user, using the fgets function, takes a string from the command line, from the standard input. And that string is allowed to be, well, the value of size is 80, which means that string is allowed to be 79 characters in size. That string is read into the character array sentence. Next, we print out a message. The line printed backward is, and then we call this function reverse, whose prototype we specified right before the main function. And this is the reverse function. What the reverse function will do is it will print all of the characters that we gave as input from the command line. It'll print them out backwards, meaning the last character first, the first character last. And how do we do that? Well, the code is simple enough. We have an if statement in here, and it's simply just an if-else block. And here's the fun part. The reverse function is a recursive function. Remember recursion from a couple of chapters ago? This is where we're putting it to use again. So this is how it works. So let's say we have a string, let's say text space input. Let's say that's what you typed in at the command line. So what will happen is this. This is passed to the reverse function as argument. And if the first character of the string that is passed to reverse, if that is a null character, it does nothing and we return. So this is the base case. Let's see what happens otherwise. Well, if we have something else going on, reverse calls, makes a recursive function call to itself, but the argument this time happens to be the address of character number 1. Not 0, not the first character, character number 1. So meaning in this case, pointing at the E of the word text, and calls the reverse function on that. So basically reverse, if the reverse function receives any number of characters, it passes the rest of the function to a recursive function call, waits for it to print out all the characters from second to last characters, to print those out in reverse order, and then it calls the put character function, the other function that we're trying out here. It prints it out afterwards, meaning this first character, this first T over here, will be printed out at the end. And how the rest of the characters are printed out in reverse order, that is the problem of the recursive call to reverse. Here's a sample run. If you give this string as input, characters and strings, this will be printed out to something like this. So you'd have to read this from right to left for it to read characters and strings. So like I said, the reverse function is a recursive function, and it basically works. So the base case is when The first character in the string that's passed to it is the null character when we're at the end of a string, when we have an empty string. And the whole scheme, the whole reason that the reverse function works is that it prints out the first character of the string after another recursive call to reverse prints out all the rest in reverse order. So it's really the order of the two statements that does the magic over here. And that brings us to another two functions, getchar or getCharacter and puts. Puts is the one you're already familiar with. So getchar, getCharacter, reads a character from the standard input, our keyboard, and returns the character as an integer. The puts function you're familiar with takes a string as an argument and displays it to the screen, in our case standard output, and adds a new line character at the end. And we've been using that just to print new line characters by passing an empty, a null string to puts. And here's a sample program that demonstrates that. Again, we have symbolic constant size set to 80. We have a main function, no other functions, no prototypes in here. And we define an integer c. We define a character array called sentence of size, meaning 80 in this case. And we have a loop control variable I, which we set equal to 0, initialize to 0. And we print out a nice little message using puts, enter a line of text. Notice that we go to the next line after that, but we do not include a new line character in that string. Okay, then we have a while loop, which goes from 0 until the maximum size of the string that we can save, meaning size -1. So it goes until the loop counter I stays within the range, within the size of the maximum string we can store, and the call to getCharacter, a call to getCharacter, does not return a new line. And as long as that happens, the character that getCharacter receives over here, so this is happening in the statement of the while loop, that character C is placed into character array sentence. And look over here, we have a post increment operator applied to I. So if you're wondering how I is changing in this while loop, this is how. And after we get out of the while loop, we add the null character into whatever place we are in character array sentence. So whatever the current value of I is. We call puts again, and we print out the line entered was, and again we jump to the next line, no new line character needed over here, and then we print out the string stored in character array sentence. So if you run this program, let's say you enter something like this. This is a test, full stop. This is read in using the while loop and the get character function we're calling in it. You hit enter at the end, and the line entered was, and this prints out whatever's in the sentence character array, prints it out to the screen. So there are two conditions for the while loop in this program to continue, and that is that the loop counter stay under 79, and the other one that the character that is received using the getCharacter function is not a new line character. And after we exit the while loop, we have to manually append a null character at the end to mark the end of the string, and we print out whatever we have read in using the puts function. And on to the next function, that is sprintf. And like I mentioned in Visual Studio, what I'll be doing is I'll be using the sprintf_s function, the secure version of sprintf provided by Microsoft Visual C. I'll be using that instead. Now, sprintf uses conversion specifiers, so remember those percentage signs, %d, %u, %s, %c, %f, and so on. All those conversion specifiers, those placeholders, are the same we have been using in the printf function. They don't change. And here's a very simple example again. This one we have just a main function. We define an integer x, a double precision floating point number y, print out a nice message using puts, enter an integer and a double. So we're asking the user to enter two numbers separated by a space. The first one is read in using scanf, put into x, that's the integer. The second one is a double precision floating point number read in into y. We then define a character array s of size 80, and then we call the sprintf statement. And what that'll do is it will put into s, which we just defined on the line above, on line 14, we will put into that this whole string. And this whole string also contains format specifiers here and here, two of them. One for the integer x, which we're going to print out as a 6-digit decimal number, and for y, which we're going to print out as a 7-digit number with 2 digits after the decimal point. And remember, we won't see anything on screen for that. So to make sure that s actually contains this whole string with the values of x and y properly formatted, we have to call the printf function. And in that one, we print out, well, first a descriptive message, the formatted output stored in array s is, new line, and then we print out whatever's in s, in string s. We print that out next, followed by another new line. So you run that, and let's say the input that you give is the integer 298 and the floating point number 87.375. So these are read into, so this goes into x, this goes into y. We do our formatting. We read that in, we read those in using scanf, and then we call sprintf, and finally call printf to see what we just printed, and that happens to be the formatted output stored in array s is integer 298. Notice the number of spaces in front of 298. That's because we specified it to be a 6-digit decimal number. And double is specified as a 7.2 number, meaning this is should be 7 digits with 2 decimal digits after the decimal point. Last one is the sprintf function, which is I'm sorry, not the last one. So sprintf function is just the one that we talked about. There's another function that you can find in Visual Studio, that is the snprintf_s function. I haven't tried that one out, but the sprintf_s function works fine. So please stick to that. So the last one for now is the scanf function, and that too has a Visual Studio secure equivalent called scanf_s. Again, this one also uses conversion specifiers. Again, they're the same that we've been using all along. And this program is similar to the previous example. So what we're doing over here is, so we have a string, a character array S, and that's already initialized to an integer space followed by a floating point number. And we define an integer variable x and a double plus precision floating variable y. They're both uninitialized. And what we're doing here is we are reading in using scanf or scanf underscore s in our case. We are reading in from string s, which is already initialized up here. We're reading it in as a decimal number followed by a long floating point number. A double, I'm sorry, LF is a double precision floating point number. And we're reading those into variables x and y. And just to ensure that it actually happened, because we don't see anything when we call this scanf function, we follow that up by a call to the printf statement, in which we print out a bunch of things, a helpful message to let the viewer see what's happening. The values stored in character array S are, and on a new line, so followed by on a new line, the string integer colon, and then as a 6-digit decimal number, the value of x, a new line, the string double colon, followed by the value of y as formatted as an 8-digit floating point number with 3 digits after the decimal point. And this is what the output will look like. Just like in sprintf, the array that we're working with is the first argument in scanf underscore s or scanf. In this one, we're reading in, like we just saw, an integer and a double from a character array s, and we're reading those in from a string instead of the keyword into variables x and y, and print them out at the end.